Hello, good afternoon and good evening, my lovely fun people. So what we're going to be doing in this video is to determine the average rate between certain time periods. So typically you're going to be given a reaction such as this methanol combining with hydrochloric acid, and you're going to see that what they do is they show you the concentration of hydrochloric acid over time. This makes sense because as the reaction proceeds, the concentration of hydrochloric acid should decrease over time, correct? Until the concentration of hydrochloric acid becomes 0, in which the reaction is done. So they give us time in minutes, right? And then they give us the concentration of hydrochloric acid. That's what the brackets mean. Remember, hydrochloric acid, or concentration of, and then the whatever's in the middle is what it's the concentration of. And they tell us it's a molarity. And the first thing they want to know is what's the average rate of reaction between 0 minutes to 54 minutes in molarity per second. So that's going to be your unit. So first thing that I noticed that's a little off is that they're asking for it molarity per second, and we're in minutes. So what we're going to have to do is we're going to have to convert 0 minutes to seconds, easy, but we're also going to have to convert 54 minutes to seconds. So this is going to equal, what I'm going to do is put here 0 seconds. So that's going to be easy. But 54, to convert 54 to seconds, we're just going to have to do a simple multiplication, which is 54 times 60. That's actually 3240 seconds. So 3240 seconds, right? So so if we know the generic term for the decrease in concentration, it's going to be, the rate is going to be negative change in concentration over the change in time. And since HCl has a 1 in front of it as its coefficient, we don't have to worry about any coefficients here, right? So for this situation, they're asking for a beginning and an end, so it goes from as long as you have 0 minutes lining up with 1.85. So I'll treat this as my my first scenario for this problem, and I'll treat this as my second scenario. So let's do 2 minus 1, the second scenario minus the first scenario. So it will be negative 1.58 minus 1.85 over, because that's what delta is, final minus initial, and then t is going to be 3240 minus 0, right? So we need to do a little calculation of that. So I get negative 1.58 minus 1.85. I get negative 3.43 divided by, oh, did I do that wrong? No, I did it correctly. Sorry, my bad. Just have to make sure. So it's a negative 1.58 minus a 1.85. And then 3240 divided by minus 0, which is 3240. So it's going to be 3.43 divided by 3240. That's going to be 1.06, we'll say. It's going to be negative 1.06 times 10 to the negative 3. And the unit is molarity per second, because the unit of this was molarity minus molarity, so this is molarity. Second minus second, so this is second. So the difference between these two, it seems to be going at an average rate. It seems to be disappearing at an average rate of 1.06 times 10 to the negative 3 molarity per second. So we're going to explore another concept here in a second. The rate, if you recall, it generically decreases such as this, right? The amount, the concentration will generically decrease this much over time. So what we're going to notice is that the average rate between different time intervals is not going to be the same. So if I want to know the average rate between time interval 107 and 430, that's going to be a different rate. It actually may be slower because, as we know, it actually starts to decrease at a slower rate. The instantaneous rate decreases over time. So let's see how we would do this. So again, 107 has to be converted into seconds. So 107 times 60, that's really 6420 seconds. And 430 seconds is really 25,800. Sorry for my, my messiness. So it's the same concept here. So I'm going to say, why don't I make this? This is now my final, and this is my initial, right? So it's going to be the concentration, which is now, it's going to be negative. And why is it negative? Because it's a reactant that's concentration is decreasing. If I were predicting the formation of something, formation is a positive thing. Something being used up, that's negative, right? So it's going to be negative, and the concentration at my second point is 0.580 minus, and initially it was 1.36. By the way, if you switch these around and do 1.36 minus 580, and you switch the values of the time as well, it actually comes out to the same answer. This is very similar to when you did y equals mx plus b and you had to determine the slope with y2 minus y1 over x2 minus x1. It didn't matter what you assigned as the pairs of x's or y's. Side note. So then for the bottom, it's going to be 25,800 seconds minus 6,420 seconds. And this is seconds, this is molarity, right? If we do a little calculation, we get negative 0.78 molarity is how much it changed over that time. And 19,380 seconds had elapsed. So this actually has a rate of, an average rate of negative 4.02 times 10 to the, let's count here, 1, 2, 3, 4, 5. Wow, that's slow compared to the earlier increment that we compared. Much slower. Recall, as the reaction proceeds, as this methanol meets up with this hydrochloric acid, as they meet up and pair up and become the products, the odds of them meeting up decreases because their concentration decreases over time. Therefore, the rate will or the amount of formation, the amount of it being used up will decrease over time. So, or the rate at which it will be used up will be decreased over time. So our numbers make sense, everything looks good. I hope this helped. This was for the rate, how to determine average rate of a reaction. Thanks.